Hi folks, so welcome to your first physics power up workouts, and the idea behind these is that we're going to home in, on specific topics, key areas, and look at how to answer questions and also to do specific calculations. So the first topic that I've picked here is Newton's second law because it's one that usually comes up in your exams, but also it is one that I know people can find difficult. Now, this is part one of the revision process, but it's also the most important one because the ideas and the techniques we're going to develop here, we're going to build upon in the later ones. So even if you feel confident about your Newton's second law, just check through this video and make sure you understand what we're talking about. So, knowledge that I'd expect you to know about Newton's second law already is you'll be able to state Newton's second law is F equal to ma, where F is the force in newtons, m is the mass in kilograms, and a is the acceleration in meters per second per seconds. Now, for our course, we have to carry out calculation using Newton's second law for situations where there are two forces or three or more forces. So what we're going to do today in this part one power up is we're going to look at the situation where there are two forces. So let's zoom in a little bit and look at the equation for Newton's second law. Now, the method that I'm going to show you is a very standard routine, and if you can buy into learning this routine, you will see the benefits later on. This isn't the only way to solve Newton's second law problems. Other teachers will show you other methods. This is a way that I think works very well if you are able to follow it and take and engage with it. So please try it out. If you can think of another way of doing it and you get the correct answer, that's fine as well. So if we look at Newton's second law, we can see there's two bits to it. The first bit is ma, which allows us to calculate the unbalanced force simply by multiplying the mass by the acceleration. The second bit, which is probably the more interesting bit, is this F. Now, F can really be written as the sum of all forces, or it can be written as F unbalanced is equal to F1 plus F2 plus F3. Now, these two statements here are actually really trying to say the same thing. And this is the bit that I'm going to focus on more because this is the part that people find difficult. And if we think about this bit, so zoom in again at this bit here, F unbalanced equals to F1 plus F2 plus F3. What does this mean? Well, first of all, we have to remember that forces affect us. And when we remember that, we have to know two other things. One is vector addition, which means we have to think about the direction of the force. And two, if we're doing vector addition, we may have to do Pythagoras and trigonometry. So for this power up lesson, I'm going to look primarily at direction of the force. So let's start by looking at a worked example. So a speedboat of mass 1,200 kilograms is travelling along a lake. The engine of the speedboat produces a force of 14,000 newtons. There is a frictional force of 3,000 newtons acting on the speedboat. Calculate the unbalanced force acting on the boat and calculate the acceleration of the boat. Now, the first thing you have to realise is there is a lot of information there, and it takes a lot of effort to read a question. So make life easy for yourself, and the first thing that I would recommend you do is a diagram which has all the information you need. Now it seems like it's a little bit more work, but once you've done the diagram, you don't need to read the question again because everything there is already presented to you and you can see it very easily. So that's the first thing that I would do. Now this question is quite nice because it leads you through to the final calculation. It says calculate the unbalanced force acting on the boat. So if we look at the diagram here, let's see how we can use this to calculate the unbalanced force. So as I said, first of all, have your diagram available. Now, the routine I want you to learn is the following. If you are calculating the unbalanced force, write out the first line. F unbalanced is equal to F1 plus F2 plus F3. Remember, the unbalanced force is the sum of all the forces acting on the object. Next step is the trickiest step because here we have to substitute in for our values. So we write down F engine plus F friction. And this is where we substitute in our values. Now, this is the bit where people can get confused. And so this is where the routine really helps you, because the statement is F imbalance is a sum of all the forces. The sum of all the forces means you are adding things together. But when you substitute in for your numbers, you put in negatives to represent the direction. And the reason for this is because, as I said, forces are vectors, so they have a direction. So when you substitute in the numbers, you've got to include the direction in there. And then once you've done this, this is the difficult part, it's a case of just applying your maths knowledge. And hopefully you know that if you're adding a negative number, that's the same as subtracting. So then we get the answer as 12,000 newtons. So let's recap on that bit. The unbalanced force is always given by the sum of the forces. So this is our first statement. When we substitute in the numbers, we always include the negative to represent the direction of the force if needed. And then we just use our math skills to work out the answer. Okay, so that was the first part. Now, let's get to the second part of the calculation, which is to calculate the acceleration of the boat. Remember, we've just worked out the unbalanced force is 12,000 newtons. So using our KFC technique, we know we've got the mass, we know we've got the unbalanced force, and we want to find the acceleration. So we've done the know it part. The find it is the equation. So we want an equation with F, M, and A. So we write it down. And we get this. Now, you don't have to include the UN bit. I always do to remind myself it's an unbalanced force. And then we do the calculation part of our KFC technique. So it's simply plugging in the numbers and you're just solving it for A. And then the answer is 10 meters per second per second. So the final stage of our question there is just using our KFC technique, know it, find it, calculate it. Now, let's take the time to review what we've done and figure out, is there a routine we can pick out to actually make this process of solving this easier? So here's the routine that I've come up with. Draw a label diagram, calculate the unbalanced force F, remember to substitute negative for direction if needed, and use Newton's second law to calculate the acceleration. So for me, if I have to solve this problem, these are the 3 steps that I've got in my head. These are the 3 steps that I follow. And if I follow these 3 steps every time, I should get the answer. So I would really recommend you try and learn this routine. How do we learn it? By practice. So hopefully you've got that routine in your head. Let's check for understanding. Try this example yourself. If you get stuck, look through the routine and see how you can do the routine, folks. Here's another example. Again, try the routine and see if you can get the answer. If you get stuck, look through your previous work, see if you can follow the routine, folks. Now, by this stage, you should be feeling pretty confident. You should have the routine pretty clear in your head. So let's try a slightly trickier one. Now, I'm not going to give you any more hints. So if you feel confident, pause the video and try this question. If you're struggling with it, just play and I'll show you some hints on the next slide. Now, as a wee hint to help you, here is a diagram for this situation. And here are some additional questions. If the diagram is enough of a hint, pause the video and wind back to do the question. If you're not sure, listen in to the rest. So think about, for example, what is the bus doing? Is it accelerating? Is it decelerating? Which direction should the unbalanced force be if it's accelerating or decelerating? What can you say about the acceleration if it was an acceleration or a deceleration? Follow your routine, because even though the situation's changed a little bit, the routine is still the same. And if you're still stuck after all those, here's an answer to kind of guide you a little bit. Let's check our answers for the third one because that was a trickier one. So I gave you this diagram as a wee hint, and we're following our routine as before. So the first thing we do is we write down F unbalanced is equal to F1 plus F2 plus F3. We then plug in our numbers. And the trick here is to remember the negative for our friction. And then we find that the unbalanced force is a negative number. Now, if we pause here and check if this actually makes sense. Well, in the question, the bus is slowing down. So if it's slowing down, we would really expect a negative unbalanced force. So that means we're on the right track. To get the acceleration, we do the following. Remember, we've got the unbalanced force as this. We're using Newton's second law, so we plug in the numbers, and then we get the acceleration, which is a negative number, and that fits in with our idea of a deceleration in this case. Finally, just to summarise, so this is worth writing down and should be part of your revision notes, that F unbalanced force is equal to F1 plus F2 plus F3. We can use vector addition in terms of direction of the force. Well, we've got to remember to put in a positive or negative. We'll look at this in the part 2 power up lesson. So the routine that I would want to learn for part 2 is draw a label diagram, calculate the unbalanced force using this expression up here. Remember to substitute negative for direction if needed. Use Newton's second law to calculate the acceleration.